Hi, so our project was the DVF. The DVF stands for Digital Vector Filter, which is this old piece of equipment which we're trying to replace with this slightly newer piece of equipment. In mechanical engineering, we have a lab where we take a look at the vibrations of this shaft system, which are second order. We measure shaft deflections through these Proximeter probes, which return large negative signals, negative 15 volts to about negative 2 volts. The task of this box, and now our box, is to take this large negative signal, which is the green line here, remove the offset,
which is the geometric shape of the shaft.
Right, which is the shape of the shaft, and then measure the amplitude, frequency, and phase of that signal. Because the amplitude and phase of that signal, as we know, forms the Bode plot, which tells us about the system.
And this is an example of data you just collected, right?
Right. This is data we've just collected. On the right here, you see data formed over a very old plotting interface captured by a plotting simulator. And over here, we have the data sent over serial from our newer device, which sends it to MATLAB. So after that, you can do whatever you want with the data, filter it, analyze it, etc.
Cool. And the inputs are a deflectometer here for the shaft displacement, right. And then there's one over here for reference.
Right. One is a once per revolution notch, which we can use to measure RPM and as a reference point for measuring phase.
Okay, so that's your zero phase.
The user interface is a whole lot more friendlier than what we had before. The old one is just a 2 by 20 character display. The new one, we have enough data density to display everything on the screen at once, completely removing the need for menus.
Nice. And this is all being driven off of a PIC32 right now.
32, right.
And a couple of ADCs.
Yep, John spent a lot of time.
Yeah, the Max 1272 ADC. Yeah, we're talking to them via SPI, and yeah, that's pretty much it.
They make plus to minus 10 volts AC measurements so that we don't have to condition the signal to that 3.3 volt range. We can keep it where it is after the offset's removed.
I see. So you maybe get a little better accuracy, more dynamic range.
We're not manipulating it so much.
Okay, cool. Okay, thank you.
Thank you.